Factory method solves a narrow design problem. A workflow knows the kind of collaborator it needs, but hard-coding every concrete class would make that stable workflow change for every new option. The pattern places construction behind a method that subclasses can define. In this episode, we will build a release notes generator twice. First as a clear direct solution, then with factory method after the design pressure is visible. Every domain and pattern type belongs to our sample. There is no ASP.NET Core, dependency injection container, or third-party package. Five participants matter. The product is the contract the workflow needs, and concrete products implement that contract in different ways. The creator owns the operation we want to keep stable. Inside that operation, it calls a factory method instead of constructing a concrete product directly. Each concrete creator implements that method and returns one concrete product. The client still chooses what it wants by selecting a concrete creator. The defining characteristics are a stable workflow, a product contract, multiple concrete options, and an overridable creation point. The sequence is simple. The client chooses a creator, the creator starts the operation, the factory method supplies a product, and the operation uses that product through its contract. Factory method changes who owns construction. It does not make the selection disappear. Factory method is a good fit when the workflow is stable, product construction varies, and the creator subclasses represent meaningful choices. Common use cases include export pipelines, parsers, and document builders. It is weaker when there is one product, when the choice is tiny and unlikely to grow, or when the caller can simply provide an existing object. Direct construction, a small switch expression, or composition may be easier to read in those cases. The trade-off is real. The pattern can protect a workflow from concrete creation details, but it adds inheritance and usually one concrete creator per product. Our example is a release notes generator. Its workflow is stable. Write a version heading, render each release change, and handle the case where there is nothing to publish. Presentation varies. One renderer produces Markdown, and another produces plain text. We will begin with a respectable direct design. An enum will represent the requested style, and a switch expression will choose the renderer once. That solution is clear, while formats are few and stable. Then we will ask what changes when a third format arrives. The answer will give us a reason to move creation without changing the generation workflow. Open the empty release change file and build the first domain type character by character. As release change is typed, its name tells us exactly what one item represents. The sealed record uses a primary constructor to receive its description. That gives us a compact immutable value and keeps the lesson focused on creation rather than mutable domain state. The complete file fits in one view, so no scroll is needed before we move to the product contract. Switch to the empty renderer file and type it naturally, one line at a time. As I release notes renderer is typed, define the product around the capability the workflow needs. It can render a heading, one change, and the empty state. Those three operations keep sequencing in the generator while presentation stays inside each renderer. Markdown release notes renderer is the first concrete product. Its heading begins with a hash, its changes begin with dashes, and its empty state uses Markdown emphasis. Before the second class moves below the editor, scroll smoothly so the whole declaration is visible. Plain text release notes. Renderer implements the same contract without Markdown syntax. Both products answer the same requests, so the workflow will not need format-specific branches while it generates the document. Move to the empty generator file and build the baseline character by character. As release note style is typed, give the caller two explicit choices, Markdown and plain text. Release notes generator receives the version and style through a primary constructor. The renderer property uses a switch expression to translate that style into one of our concrete products. This is modern C# and a reasonable design. The renderer is chosen once instead of once per line. Now type generate. I read-only list says the workflow only needs to inspect the changes. The lines collection begins with the rendered heading. If the collection is empty, the workflow asks the renderer for its empty state. Otherwise, it walks through each change and asks the same renderer to format it. Scroll before the loop approaches the bottom edge, then keep the complete return statement visible. String.join combines the result with the platform new line. The baseline already depends on our product contract and keeps the sequence in one place. Switch to the Empty Program tab and type the client one line at a time. As I read-only list of release changes typed, state the client's only collection requirement. The collection expression creates two original changes for version 2.1.0. Next, construct one generator with the Markdown style and another with plain text. We print two deliberate cases. The success path sends the populated collection to Markdown. The boundary path calls the plain text generator with an empty collection expression. That empty call is useful evidence. The workflow decides when an empty state is needed, while the selected product decides how it looks. Keep the complete output block visible before opening the terminal. The baseline compiles and runs. The success path produces a Markdown heading followed by two list items. The boundary path produces a plain text heading and no changes to publish. Both results are correct. That matters because the direct solution is not a mistake. Factory method should answer a change pressure we can name, not replace clear code merely because a pattern exists. Now imagine that release notes also need HTML output. Writing an HTML renderer is expected. A new product deserves new product code. The structural cost appears in the existing generator. We must reopen release notes style, add another enum value, then reopen the central switch expression, and add another concrete construction branch. Every new format repeats that path. The stable generate workflow now sits beside a growing catalog of concrete classes it does not otherwise need to understand. This is not a performance problem, and switch expressions are not bad. The issue is ownership. Product construction changes more often than the workflow, so we will move only that decision. Return to release notes generator and rebuild it in its final form character by character. The enum and style parameter disappear. Release notes generator becomes abstract, but it still owns real behavior. The entire generate workflow remains here. Inside that method, a local renderer now comes from create renderer. As create renderer is typed, make the seam explicit. Its return type is iReleaseNotes renderer, so generate still works only with the product contract. Near the end of the class, declare the method protected and abstract. Protected keeps it available to subclasses without adding it to the client-facing operation. Abstract requires every concrete creator to make the choice. Scroll before the new classes move below the editor. Markdown release notes generator uses a primary constructor, forwards the version to its base creator, and returns a Markdown renderer. Plain text release notes generator follows the same shape. These overrides are small on purpose. Each records one creator-product pairing. The workflow no longer owns a central list of concrete renderers, and no framework owns the lifetime or construction. Switch back to program and rebuild the client with natural typing. The release data and output calls stay the same. As Markdown release notes generator is typed, move the application level choice into the concrete creator name. Plain text release notes generator handles the boundary path. The client still chooses a format. Factory method never promised to erase that requirement. What changed is the owner of renderer construction. After construction, both variables use the release notes generator creator type and expose the same generate operation. The renderer classes never appear in program. Keep both creator lines and both calls visible before the final run. The refactored project compiles and the output is unchanged. Markdown still handles the populated success path. Plain text still handles the empty boundary. Generate still decides when to render the heading, when to iterate, and when to use the empty state. The concrete creators decide only which renderer to build. That unchanged output is the proof we wanted. The structure around object creation changed without changing the workflow's observable behavior. Factory method earns its place when a stable workflow needs products whose construction varies and concrete creator types make sense in the design. It costs more classes and introduces inheritance. If this application will always have two trivial renderers, the baseline switch expression may remain the clearer choice. If a renderer should be supplied directly and changed independently at runtime, composition or strategy may fit better. The difference is intent. Strategy varies behavior through a supplied object. Factory method lets a subclass decide which object the creator builds inside its workflow. The selection still exists somewhere. Here, program selects a concrete creator, and that creator owns one product construction decision. The reasoning path is more useful than memorizing class names. We started with a stable release notes workflow and two variable renderers. The direct switch solution worked and stayed readable. A growing product family exposed one concrete creation decision inside the stable creator. Factory method moved that decision into concrete subclasses while generate continued to use the product contract. Before applying the pattern, ask 3 questions. Is the workflow stable? Does product construction vary? And do creator subclasses represent meaningful choices? If the answers are yes, the extra structure may be justified. If not, keep the direct design.